Another way of visualizing a 2x2 table is through something called a mosaic plot. A mosaic plot is useful because it can help you to visualize the unconditional and conditional aspects of a contingency table. So a mosaic plot, one way to think about it is how you construct a mosaic plot. So there are really two main steps when you construct a mosaic plot. First, you just create a square. And that square is divided into two vertical bars, or 3 or 4, but the whole point is you have the same number of vertical bars as you do levels of a categorical variable. And for these vertical bars, the widths of each bar, it's proportional to the unconditional distribution of a categorical variable. So if you have 2 levels of a categorical variable, then you have 2 bars. And then the degree to which there are more observations in one category versus another, you have a different sort of proportion. Next, what you do is you take each bar and you split each bar horizontally proportional to the conditional distributions of some other variable. So really, to understand this process, it's best to kind of go through an example. So first, we're going to take a square and we're going to divide it into vertical bars whose widths are proportional to the unconditional distribution of the first categorical variable. So our first categorical variable is whether you survived or didn't survive the Titanic. So if we look at the proportion or the percentage, we can see that 59% of people overall did not survive the Titanic, and then 41% in fact did survive the Titanic. So when we create our square for a mosaic plot, this suggests that the width of the vertical bar for those in the no category, it's going to be a little bit larger, because we're going to reflect visually the unconditional distribution of survival. So you can see that this darker bar, it's a little bit larger in terms of its width because 59% of people did not survive. And then the bar representing those who did survive is a little bit narrower. So we've created a square and we've divided the vertical bars equal to the number of levels for our first categorical variable, and the width of each bar is proportional to the unconditional distribution of the first categorical variable. Then what we do, we split each bar horizontally proportional to the conditional distributions of the row categorical variable. So our row categorical variable is going to be class. So we're going to look at the distributions of class conditional on whether you survived or didn't survive. So this is just reflecting the different conditional distributions of class. So you can see here that the two vertical bars, they're the same width, reflecting the unconditional distribution of whether you survived or didn't survive. But you can see that for the horizontal splits, we have a different distribution for whether those who didn't survive and versus for those who did survive. So what the graph is telling us is that overall, a greater percentage of people among those who did not survive, a greater percentage were in the lower class. And among those who did in fact survive, a greater percentage relatively were in the upper class. And you can see this visually in the mosaic plot. It is just reflecting the conditional distribution of class. It's reflecting the distribution of class, conditional, and survival, to put it another way. And the great thing about a mosaic plot is it conveys a lot of information in a relatively concise way. So it accords with the principles we discussed earlier about good statistical graphics. So let's kind of think about how you might make a conclusion based on a mosaic plot. So if you just look at the width of the bars overall, just looking at the column variable, which gives the unconditional percentage or unconditional distribution, you can see that overall more people died rather than survived the Titanic. That reflects the greater width of the bar for no. But then if you look at the sort of vertical splits, the conditional distributions, you can see that among those who survived, only a small percentage were from the lower class, but among those who died, a really large percentage were in fact from the lower class. So we can also think about a mosaic plot in which we flip the column and row variables. So in this example, what we're doing is we're looking at the class variable as the unconditional distribution variable, and then the row variable, the variable on which we're conditioning, creating these conditional distributions, is in fact whether you survived or not. So to put it another way, this reflects a table in which we have unconditional distribution of class and a set of conditional distributions for whether you survived or not. So in this case, we can make conclusions as well. We're just conditioning on a slightly different, on a different variable. Overall, a greater percentage of passengers were in the lower than upper class. So this just reflects the unconditional distribution of the class variable. Most people overall in the Titanic were in the lower class, and then roughly equal proportions were in the middle and upper class. But then we can look at the horizontal splits, and we can see that conditional on the values of whether you're in the lower, middle, or upper class, what percentage survived or didn't survive. So conditioning on, looking at those who were in the lower class, we can see a greater percentage, in fact, did not survive. And then looking at those in the middle or upper class, we can see that, in fact, a smaller percentage didn't survive. In fact, most people actually survived, conditioning on whether or not you were in the upper class. So looking, just subsetting the set of data to those in the upper class, we can see more people survived than didn't survive. And this is reflected in the mosaic plot. The important point about a mosaic plot is that the column variable, the variable at the top, is based on an unconditional distribution, whereas the row variable, it's giving us the distribution conditional on the values of the column variable. To put it another way, the row variable is giving us a set of conditional distributions. So it's really important when you create a mosaic plot to keep track of what you're conditioning on. Are you conditioning on class, or are you conditioning on survival? The distribution of survival conditional on class is in fact not the same as the distribution of class conditional on survival. So always ask yourself, what am I conditioning on? What are these percentages or proportions of that I'm calculating? So when we talk about two categorical variables, there are a few things to keep in mind. If we're interested in the cell counts of a contingency table, dodged and stacked bar graphs can be very useful. Mosaic plots can be used to visualize the distributions of a contingency table, with the key point that in a mosaic plot, the column variable is based on an unconditional distribution, while the row variable is based on a conditional distribution. And with that, we conclude our discussion today of visualizing two categorical variables.